Welcome to the Japan Expert Insights room on Thursday morning. Today we continue our conversation with Jovan Rebolledo, who is a researcher and innovator and who works in the fields of robotics and mechanoinformatics at the School of Information Science, the University of Tokyo. So let's see what we have today. Jovan, let's start. So thank you very much for coming, everybody, once again. And Jovan, shall we start?
Sure. Thank you again for the invitation. Thank you so much for the intro. And yes, you're right. This unicorn thing has been calling the attentions of many people. And before jumping to that, I would like just to make an introduction that it could be the perfect interface between the last talk and this talk, which is the why Japan became very attractive or very renamed in robotics around the world. Basically, what I can see from 2 points of view is the first a bipedal robot that was from Waseda University that really started the imagination. Like, for instance, what we saw with Elon Musk last weekend. It is definitely the product of the efforts and the technology pushed in Waseda for the first bipedal humanoid. That version is really, it looks like a Frankenstein, and it's very unstable, but it was an amazing achievement. And I believe that another point that has to be recognized is the efforts from Kitano Sensei from Sony. So he has been pushing robotics so much in the robotics competitions. So he and his team and with other researchers and Sony people from Sony, they saw the real need of evolving robotics faster if there's a competition like football, soccer, in which the robots have to play as if they were in players of the soccer game. So these competitions started in Japan, and then they became so popular and so attractive around the world. So this, among the topics that I couldn't cover last time, I think these two really make the icon of Japan as a very robotic, advanced, robotic think forward country and society. So but there's a thing that I've been finding when I had the privilege to come to Silicon Valley to be in NASA for 3 months, to be taking the course of the Singularity University among Ray Coswell, Peter Diamandis. They were the teachers, and a couple of the PayPal mafia, for instance, the Larry Page. That time he was the CEO of Google, and many other people who came to Singularity University to teach that summer in 2009. I learned very fast, and I got very well impressed of the term of exponential technology. And when I came back to Japan, and I was finishing my PhD in computer science and engineering, and I was telling everybody, like, exponential technologies, like we really need to advocate exponential technologies, and it was frustrating to see that no, it was 2009. It doesn't seem too long ago, but it actually is. And many people was like, "Oh, well, what do you know? Just about to graduate, PhD student. You don't know anything." Kind of that feeling. And I was a little bit kind of to understand that the fast adoption of technologies and how to implement and innovate very fast is a mindset that I'm so privileged and fortunate to be able to to learn directly from people like Ray Kurzweil, Peter Diamandis, Peter Thiel, etc. And when I came back here, I saw, okay, what is then innovation here in Japan? I was a struggle, and that's maybe the main motivation of why I put together these could be seen like randomly terms like exponential technologies, deep tech, and DX. So if we go a little bit in the time frame and timeline, we should start talking about deep tech. Indeed, deep tech or hard tech is a classification of organization, or more typically startup companies, with the express objective of providing technology solutions based on substantial scientific or engineering challenges. So this term from 1998 has been used in R&D, research and development divisions in companies like Raytheon Technologies or Lockheed Martin's Works and Bell Labs, to the more modern definition, which increasingly includes companies found in the venture capital ecosystem. So I'm paraphrasing and also reading a little bit. I should be very fair that some of the entries in Wikipedia about deep tech. So the roots of deep tech, it's very well correlated with the scientists trying to put a new technology to invent from almost ground zero to up to a very stable technology. So this requires tons of money and tons of people in teams, etc. So it's very expensive. And this deep tech has been popularized, has been adopted by the basic ecosystem, because there's some of these VCs firms prefer to invest in companies that have a solid background, a solid experience in the technology they're building. So, for instance, in Singapore, in the recent years, maybe from 2012 or so, the deep tech technologies companies are usually startups that come from laboratories, uh, laboratories that are in universities or research institutes. And having these research institutes and these laboratories have a lot of resources, and they can absorb or the shock of the risk and the technical risk, while the market risk is often significantly lower, though, due to the potential value of the solution to society. So there's a justification of okay, there's a lot of risk, so let's invest. And there's a lot of smart people here in this lab. Let's create this thing. So the roots of the deep tech, it's a lab with at least a couple of scientists dedicated 100% of the time. So what are the futures of deep tech if we put it together? So deep tech obviously is motivated to create new markets or disrupt existing ones. But what they produce, the deep tech in laboratories, is a proof of concept, and it needs long time to move from basic science to commercial technology. So that's why many of these deep tech related technologies, they need government grants for research and development. So that's why the money from the government is usually spent on these very risky ideas, technological ideas. And so VC is not that risky in that way to bet and to put the money into these very disruptive technologies. So this happens at the end. This term was started to be used a lot towards the end of the 90s. But then came the book, The Exponential, The Singularity is Near, from Ray Kurzweil. So The Singularity is Near is a book that I strongly recommend to everybody. Even though I was looking these last days at it, it feels a little bit old in many ways, but it still has a very, very amazing core spirit and mindset. And what The Singularity is Near from Ray Kurzweil tells is not just about the Moore's law, but it's about the how the microprocessing, or how the information, processing the information, comes in an exponential way. So I'm going to be talking a little bit about terminology, but I would try to avoid very technical ones. But to be very clear, like Moore's law, it's based on the silicon technology, silicon chips based in silicon. So everybody is saying, "Oh, the Moore's law is going to finish next year. Oh, the Moore's law is finishing now." But the reality is that even though the silicon is still being challenged every day with microprocessors, the distance between the MEMS and the circuits being smaller and smaller, from 12 and 10 to it was thought to be the limit of the distance, 10 nanometers. So now Apple, for instance, is doing computers. You can buy computers from Apple, the newest ones, who has 6.5 nanometers. And in IBM recently, a couple of months ago, had a breakthrough of 4.5 or 5 nanometers. So this distance between what the computing is made and the chip is getting lower and lower, even though that they thought, because the atoms, they are very big, so they cannot, they would be a shortcut. They cannot produce the processing that they need because of the atoms are very big. But that's not the case. But Moore's law is just about the silicon-based chips. But what Ray Kurzweil found, and I think it's very profound, is how processing technology, processing information based on the cost of this processing information is exponential. It follows an exponential curve. If you plot it, if you put it together and you see, okay, how was the processing of the information 100 years ago and how it is now, and you go on the different iterations of technologies, you can see very clearly that it's an exponential curve, and an exponential curve has the characteristic that is doubling or tripling the previous value in the next iteration. So what Ray Kurzweil did that is very, very interesting. He went before the silicon-based transistor, and he went to the vacuum-based technology, in which there was the very initial computers, and even before that, he dared to go even to the how people were printing books and what was the speed of printing books, for instance. So this processing information, he calculated on how expensive it was and what was the speed of this processing. So he came all the way from centuries ago to the start of the computers with the vacuum technology, to the silicon-based transistors, and continue to the next generation, which he calls the stack computing, in which it becomes not just 2D, but it becomes for 3D 3D chips. So he understood that the the very nature of the speed of how humans are able to process information is doubling every year almost, and it's one means or another means. It could be this last 50, 60 years, it turns to be silicon-based chips, but maybe the next 30 years is going to be quantum, and then after it's going to be the next thing, and before that it used to be something else. So it's not about Moore's law. Moore's law is just about the silicon base. But the he makes what is amazing in this, because he understood this concept of the speed of change, so he can foresee the future. He can see, okay, we are here now, but if we go like 10 years, we can do this kind of processing. We can pull this data and we can feed the system, and we can create this technology. So that's what I had the very fortune to learn directly from him his way of seeing the exponentiality in the processing of technology. So we have many different cases of the exponential technology going exponential. So for him, for in the book, it tells many different examples. But from Singularity University, we divide 4 different fields of exponential technologies, which one is robotics and artificial intelligence. Another one is digital biology, which it comes to CRISPR-Cas9, etc. And another one is nanotechnology. Another one is IoT, Internet of Things, and networking, etc., like 5G, 6G, etc. So those are the pillars and the foundations, the 4 different foundations of technologies. And we in the book you can see different kinds of exponential technology examples. Like for instance, the data of gene bank of how many sequences of different species are growing exponentially, or the RAM, the random access memory's capacity, the cost, or the magnetic data storage cost, the price performance, wireless communication, speed and cost, the number of internet hosts, the number of internet data traffic, the internet backbone bandwidth, the decrease in mechanical devices, the size, the nanotech citations in publications, and US nanotech-related patents, etc., etc., etc. So all of these examples obey or show a very clear exponentiality in which it is basically all these technologies follow an exponential. And what are the features of exponential technologies? Well, it creates new markets or disrupt existing ones, as well as it was in deep tech. But it goes for the proof of concept could be very fast, rapidly innovating to from basic sciences. So usually the startups that you apply exponential technologies, usually they don't need a government grant for starting up. And early stage funding for R&D and prototype development have a quick life cycle. Fast iteration and fail quickly are very attractive to both the angels and VCs. And fast innovation usually requires the convergence from 2 of these exponential technologies or 2 of the deep techs that are mature enough. So they create a sub-exponential technology. So this concept of exponential technology, I see very clearly, like people in America, for instance, they grasp it, they use it very well. But I feel a little bit of struggle here in Japan in understanding this concept, not understanding, putting in practice this concept of exponential technologies. So if we could define it, exponential technologies would be like any method that processes information that follows an exponential reduction of cost and or exponential growth in its processing of the data or the information. These technologies are usually used in products or services where its data is digitized. The classical examples are AI, robotics, digital biology, telecommunication, nanotech, quantum information processing, and quantum computation has also, they have exponential nature in themselves. So basically, the exponential technologies is any method or technology that has the law of accelerating returns. Accelerating returns is this exponentiality that they follow every cycle and doubling the power and cutting in half the price. This accelerating returns embedded in the exponential technologies. So these are deep tech and exponential technologies. 2 concepts that could be related and not they overlap, but they are really different. So it was very interesting that up to when I came here to Japan, I started hearing a lot of and DX and digital transformation, and I was a struggle like why X and why D, and I read about it and one of the even in the Wikipedia I believe they say that the X is used in English for abbreviation of transformation, which I'm not sure about it. That's very true or not. But if I think about it, X could be used as exponential. So I believe that the roots of this dx, the abbreviation of the X, is more possibly related to an exponential, meaning uh, obviously related with transformation, but the X at the end, it means exponentiality for required to be the transformation. So I might be completely wrong on this, but that's my my guts telling me that the right thing of the X and the digital and DX is more about exponentiality than that enables transformation, obviously. So this DX, it's speculated that it started in 2004 in Swedish University professor Eric Storterman. So it's not completely accepted that, but it was more likely clearly articulated after Klaus Schwab came with the concept of the fourth industrial revolution in 2015. So this Davos thing and all this World Economic Forum, they enable the wording of DX more articulated. The year is 2015. So just a brief parenthesis. If you would talk to deep tech, is around the 90s, the end of the 90s. Exponential technologies, which is the beginning of the 2000, the middles of the 2000, 2005, and DX, which became very popular after the World Economic Forum, 2015. So the phrase for industrial revolution was first introduced by a team of scientists developing a high-tech strategy for the German government. So Klaus Schwab, executive chairman of the World Economic Forum, introduced the phrase of a wider audience in a 2015 article published by Foreign Affairs. And I'm reading again the part of the Wikipedia article of the Fourth Industrial Revolution. So then here in Japan, that was very interesting. I had a chance to come to the some of the cabinet members invited me to talk about the society. They introduced the society 5.0, and I was really surprised because until that moment, that was in the cabinet, I never heard about Society 5.0, and they were very excited. I was so excited to learn from there that so Society 5.0, as you were maybe so much better than I, because I just happened to learn from 2016, 17, which it was possibly the year that the Japanese government started to implement this strategy, the fifth term of the Science and Technology Basic Plan. So the Society 5.0 is a new society that balances economic development and the solution of social issues through a system that highly integrates cyberspace, virtual space, and physical space. So this we do a following of the fourth industrial revolution, and Japanese government taking this and evolving into Society 5.0, and then using the term DX. So the term DX, as I see it, I might be very wrong, but as I see it, it evolves even here in Japan. And so the report of the National Institute of Advanced Industrial Science and Technology cited the following 6 themes of elemental technologies that are required, or they are required to develop the Society 5.0. So it's the cyber physical system, the innovative hardware technology, autonomous evolutionary security technology for AI application, information input-output devices for high-efficient network technology, next-generation manufacturing, and innovative measurements technology for digital manufacturing. So the Ministry of Economy, Trade, and Industry cites IoT, big data, AI, and robot as key description for the realization of Society 5.0. So Society 5.0, I think in the last year or so, because of the SDGs, the pushing of the Gs and integrating the SDGs into the concept, and the Sozo Shakai, for instance, the imagining society, this DX also reshape a little bit. And from I see it is really more about AI, robotics, IoT, and 5G that Japan means to implement. And also DX is more helping the current companies to transform themselves. It's not about starting something new that is disruptive. It's what we have now, let's evolve it to the next stage. So the features of DX, well, obviously there's a very strong also, I need to say, the monosecurity DX, which is a very strong force, obviously, because Japan is very concentrated in monosecurity. So if I see the features of DX in Japan compared with the other features of deep tech and exponential technologies, the DX in Japan is mostly related to AI, IoT, 5G, and robotics to improve current businesses, not to create new possibilities. There are canvas and templates that could help for fast implementation of this. Investment comes initially and on from the government and might not disrupt markets. And it's difficult that these DGs could create many new markets. So this, if we can see there is overlap among the three deep tech, exponential technologies, and DX, but there are clear differences. And I think understanding this difference, and also, as you all might agree, that languages evolve, that the Japanese that was spoken in 1980s is not the same as what is spoken now, and the English also absorbs new words all the time, etc. So these concepts might evolve in the future as well. But having an understanding of how robotics in Japan are related with this deep tech, exponential technology, and DX, it's very, very interesting, I believe. So we can all learn and maybe apply what we learn into creating a better future together. So I would like to make a pause here, and maybe if anybody has any question, any comment, I might have made mistakes in saying something, especially talking about Society 5.0 or DX. If anyone has any comment or question, please, it's very welcomed.
Yes. Everybody in the audience, let us know if you have comments, questions. Just raise your hand and we'll invite you on stage. So this is fascinating, Jovan. Thank you very much for this wonderful presentation. Because I don't work in this field, and I really was not aware of the differences between the different terms. So thank you very much for making this clear. Sam, good morning. And Ren, good morning.
Good morning. Hey, good morning. Thanks for bringing me up here. Really interesting stuff, Jovan. Thank you for sharing so much. I do work in tech, so I guess I'm a little bit more familiar with some of the terminology, but I guess what I wanted to ask you was specifically about, you mentioned about, kind of the technologies. And I think early on you said about how, a lot of VCs, they want to invest in these things that are coming out of these labs now because they've kind of the risk on the tech side is already managed. And it just seems kind of poignant for me that if you look at Japan and what you were talking about with the kind of digital transformation being focused on, not let's build disruptive new businesses, but let's kind of try to improve and change what we have already. Obviously, you're deeply involved in the technical side of things. So maybe I don't know if this is really relevant for you, but one thing that I always think about is that a lot of these companies that are really innovating these new technologies, these kind of big, well-known startup companies, right, that have really made it, the Googles and the Teslas of the world, they also had to innovate business models, right? And it wasn't just about, oh, look, we made these great electric cars. It's, well, it's all this software platform and this, how do we monetize like digital services? And um, I think that in Japan we've seen such a unwillingness to change the business landscape to where things that you say there's an obvious value, like, well, we can point to the kind of cliche of, well, we're still honko stamping and faxing things to each other, and we've had the exponential solutions for those for 30 years. um, so I'm just curious, you know, I guess I want to get your opinion maybe, or your take on, you know, do you see that, is there kind of an adoption of these kind of AI IoT technologies happening in the background that we're not really seeing? Or do you think that there's some kind of, do you think that this strategy is the right thing? Do you think it'll get it done? I'm just kind of curious. I know that's maybe a big question.
Yes, thank you so much, Sam. It's a very interesting question. I think the answer would be like hybrid. What I have seen, what I have talked, and I can point out a very personal example of a good friend who works in one of the top industrial display manufacturers in Kansai area. So he is one of the scientists creating the next generation displays, and uh, we've been talking. He wants to get away of the company because he says like, oh, this company is very nice. They treat the employees very well, but they are just so much attached to the technology they have. They prefer to keep selling what they have than to start selling something new that is so much better, that has many features, has solves many new problems, because they are kind of attached to that, those models of selling, those models of producing, and all these. They are accustomed, they're used to doing this. So he wants to make a startup of using a new kind of display for robotics. So I think I see very very well this maybe awareness inside the companies that this need to change, and somehow people like nature, like organically, is changing inside out. And on the other way, there's a very interesting company called Livanest. The founder is an acquaintance, I could say friend in the past. He's a good guy. Uh, Livanest is a very, very interesting example. They started literally, they say, we were looking at Singularity University every day in the website, and we try to copy everything that they have in the next day and then the next day. So we try to implement what they were doing in the Silicon Valley. And that model, by the way, has been made in many companies, even for instance, like Rakuten, how they became so successful by just imitating what Amazon was doing. So Livanest, they started like that, and they became very strong and it's a very nice company. They invest a lot in startups, but it seems very clearly now that they change from this very entrepreneur-based innovation and let's change the society in an entrepreneur way to deep tech based entrepreneurship. So now uh, I can see a preference maybe when you see the grants that they do and the funds that they do to funding the people who have a PhD, and so they research like 3-5 years of the technology, and they want to do a business with that, which is perfectly fine. I love it. Don't get me wrong, I love it. Uh, but I think it is still different that investing in what it could be exponential technologies, and I think this change. I don't know the forces of why Lebanese turn itself into a more from exponential technology to deep tech. I really don't know the forces, but I could imagine them, but I don't have the facts. So I think these two things are happening dynamically, and I believe inside the Japanese society, the population, and many foreigners, by the way, we want to push the fast transformation and the fast innovation as exponential technologies could enable in startups, rather than deep tech. And coming from me, that I am a researcher in artificial intelligence. I've done a PhD and a couple of postdocs, but I believe that the way to go is to do in the way of entrepreneurship of exponential technologies. Uh, Maybe a balance could be very healthy indeed, but I think it's needed to be empowered and celebrated these exponential technologies a way mindset for solving problems in Japan. Yes, thank you so much.
Yeah, thank you for your reply, Jovan. I think that's really interesting. Yeah, I think it's good to hear that there's kind of the internal transformation going on. So thanks for sharing.
Thank you. And Ren, good morning.
Good morning. Yes, good morning. Good morning. And Jovan, thank you very much for another thought-provoking topic, a lot of food for thought in the morning. And I have a couple comments and questions, if I may. The dx, x is not a transformation, but more exponential. That's what x means. That was very interesting viewpoint. I really enjoy listening to that. Maybe I should also point out that the X, as you may know, also means God. So like Christmas, right? So that's maybe even another way to look at it, because the singularity may be bringing machine or human beings together one step closer to God. Maybe that's maybe just my imagination. But X means many things, and I thought that was a very interesting take on your part. And the other point is this Society 5.0. I'm more familiar with something called Industry 4.0. The Society 5.0 is still new to me, and I just Googled Society 5.0 while you were talking, and I found out why I was not familiar with Society 5.0, because it seems this is a more Japanese or Japan-born term. It's now widely adopted overseas. That seems to be the case. Is that true or not? And that's question one. And question two is, I see many similarities between Industry 4.0 and Society 5.0, because they both try to use automation, data exchange, including cyber physical systems, Internet of Things, cloud computing, cognitive computing. The only difference seems to be creating a smart factory or creating a smart city. But I'm sure there's something that the society technologies are needed in addition to smart factory technologies. So these two questions, if you could shed some light, would really appreciate it.
Thank you so much, Ren. Yes, I completely believe that the Society 5.0 is a Japanese origin, a term and a concept, in which I think also it's very, very interesting how the society is very important, how we could use AI, IoT, robotics to enable the societal transformation. And of course, Industry 5.0 is international concept, but Society 5.0 is I think, just Japan. When I had a chance to come to the cabinet, I went with one of the Singularity University leaders, and they were very in the building. They were very kind of explaining how they evolved the concept from the fourth industrial revolution to be applied into the society, and it was so interesting. And we love it. Like we talked later with Pascal, this person from Singularity University, and he was very, very impressed. And he said, "Well, that's a very, very good way to go." He's German and he lives in Silicon Valley, and he was one of the founders of Mozilla. I think um, Society 5.0 is completely Japanese, I believe. It was created in Japan by the Japanese government to utilize these new technologies into an applications towards the benefit of society, and in a very kind of Japanese way of seeing it, which I really, really like it. And I don't know why it hasn't been expanded to other countries. I don't know if the marketing or I don't know. I don't know. I truly believe many countries would be very happy to learn so much more. For instance, I learned that a couple of Latin American countries where they were having special seminars about Society 5.0 to try to implement in the countries from the Japanese government. So this education cross countries will be very, very interesting to see more and more. And yes, I think yeah. I think I forgot the other question that you had.
Yeah,
Sorry.
no, sorry, I should ask one question at a time. The industry that I'm more familiar with is called Industry 4.0, the smart factories. I think there are so many things that can almost directly apply to society for 5.0. And then I'm sure there are some additional things that Society 5.0 will be requiring technologists like us to do. And if you have to pick one thing that is significantly different, in addition to what Industry 4.0, the smart factory, is required, what would you pick? I have my favorite, but I would like to exchange our opinions each other.
I would choose the assimilation of robotics. If robotics could be integrated into society, our lives could be so much better in many regards, from many things. And I've been seeing this integration, organic integration. There was an architect, sorry, I don't remember the name, a Japanese architect who is designing the new houses, taking in account the self-delivering systems that are coming. So people don't see these little cars coming, and they have a special garage that they come, and also for the drones to drop out. So this integration, I love it. So also robotics inside the house to help not just the Roomba, like the Roomba has been very, very successful, but integrated more in the kitchen, in little things that make the life so much more easier. I think that would be excellent. And obviously the teleworking and robots, you can teleoperate, you can scale yourself. I think for me, the most important thing about teleoperation robots and telerobotics is not you are transported to another place. But I think the very, very good thing that could happen is you can scale yourself. So instead of using just one robot, you can manipulate two robots at the same time if the task is very repetitive, and you just need to do the same movement in a line. And you can do like 2, 3, 4, 5 even. So you can multiply yourself. So that's what a telerobotics could enable. So instead of having just one worker who's working in a factory, you can have just one person, like physical person, manipulating 5, 10 robots at the same time. So that's something that is so interesting, and I think it should be explored more. And Japan, I think, is catching up on this.
Yeah, it's very interesting you mentioned that, because I think in my humble view, I think the companies, especially big companies, when they want to build new factories, before we tend to try to build factories where we can find laborers, find people, hiring people, right? I think with the technologies that you're doing, companies will now be looking for resources like more water resources or more electricity And then human factor could be the lower priority because of the work that you're doing. And I think that's really a game changer in my humble opinion. And that's my comment back to you. And I also like to point out, since we're talking about this, in the last 24 hours, there was a very interesting news about Google. Waymo is trying to do a robot taxi in San Francisco. And would you like to share, or would you care to share a little bit about your view on this Waymo news in the last 24 hours, which is not very well covered in major newspapers in Japan. So, but I think it's a big news. But I'd like to hear your viewpoint. Thank you.
Yes, thank you so much. I had the very privilege to talk to the one of their main researchers in 2010 of the lab that was running this self-driving car testing, and I love to see every year. I used to come to Silicon Valley and see the new iteration of the Google, and then when it became their own company, the Waymo, it was very, very nice to see how it was evolving. And it was a little bit strange how to see the Tesla not just catch up, but also like past sometimes without any notice the Waymo. So I think, but anyway, like I just read it very quickly yesterday. So I know that they're starting operations in San Francisco, but I believe that that's the way to go. Also, Uber used to have, I think, in Colorado. I'm not remember exactly the state. They also were running pilots of self-driving cars. So San Francisco is very interesting because the legislation didn't do it, and so that's why many companies like Uber tried in other states. So many things that a self-driving car have been not fulfilled is because of regulation in California. And that's something very, very strange. I happen to know one of the founders of a car sharing company, and she pushed the legislation for the car sharing in 2009, 2010. So thanks to her, she opened the doors for Uber and other companies to start doing. But the legislation in California is not usually the best. But the nice thing is like it can change, and I think that's maybe the very positive output. I would say that the legislation didn't permit self-driving cars in California, but now it's possible. So this adapting, sometimes the government takes long time to adapt, but I think California, maybe it's one of the features. Even the government, they adapt relatively quicker than any other part of the world. So I love it. I think that's the way to go, and taxis, self-driving cars will become more a way to work. You can commute, doing things, etc. So I think it's the really way to go.
Thank you. And since this room is about robotics in Japan, so my last question on this one is, how these things that you are describing about what's happening in Silicon Valley, how would that affect Japan? Do you think Japan will move even more quickly because of what's happening in Silicon Valley? And because you were in Japan, we are all in Japan. How do you see Japan's eagerness to speed up these things when other countries are making these kind of progresses?
I really think that when Japanese leaders, they commit to something, they really do it. So I hope, this is my personal hope, that this is an inspiration for committing to a very fast change. What I have perceived is not exactly the fast change that I would like to see. And somehow I also see some kind of attachment to European Union, EU policies. And that's a part of the thing that I want to share, that, for instance, the investment in in artificial intelligence, obviously United States, for instance, data from Stasia, so it tells that it's $23 billion, almost $24 billion, while China is almost $10 billion, and EU is $2 billion, and Japan is still a couple of places away. So the amount of investment compared of EU compared with the United States is less than 10 times. So I think Japan should choose sometimes and not to be too attached to the EU policies. I really see the good things of doing and having different frameworks to choose and combine and learn from. But I think maybe the policymakers here in Japan should concentrate more in enabling and imitating the policies happening in US compared to the EU, because EU is behind, and I think there's still a very well coherence of having a priority in society like EU does, and also having the innovation input as an innovation force as California does. So it's not mutually excludent. It could be combined. So I think this maybe awareness of doing this, I think that would be the best to see, and I hope it could happen.
Thank you, Maya. Thank you, Timothy.
Thank you. Yes, it is fascinating how, to your point, Jovan, when you said that human beings or employees can scale themselves. So this really sounds like, the perfect solution to decreasing population in developed countries, in some developing countries as well. And so how it will basically improve the quality of life and life in general as well. So of course, as Ren said, that's probably the race for resources will be the next one, and that will be the next thing, probably the challenge when we actually move towards the SDGs. But still, it is just wonderful to hear that there is a bright light at the end of the tunnel at this point of time too, because a lot of people tend to say that the decreasing populations are actually are going to be a big problem. But if we apply robotics and use them, it seems that
exactly.
Yes, thank you for
that.
Yes,
yes, Ren.
Yes, Maya, just one point since you mentioned that.
Yes.
There was an interesting article today in Nikkei, Nihon Keizai Shimbun. Yeah, they mentioned the problem of what you said. How should I say? There are many countries that are having the same problem like Japan does, which is the aging population, right?
Yes.
But there's a hidden bigger issue. A lot of these countries, they did not reach per person GDP level as Japan, but then they are already faced with the aging population issue. I'm not sure I explained this well. Did you understand what I'm trying to say?
I think I do.
That's an interesting way of looking at it. So those countries, their problem will be even more severe than Japan has, because they have not reached that industrialization, but they are already faced with the aging population issue. So this is another area where what Jovan is doing is going to help these developing countries aging issue, I think.
But it sounds to me that Japan can set a wonderful example, and this is where basically what Japan develops, the solutions Japan develops now, or maybe in the next 5 to 10 years, can be scaled, and then they can be exported to countries which have not reached that GDP level yet. So probably that's where, the future of the Japanese industry lies too. We never know, but this is certainly an opportunity.
Yes, absolutely. I would like to add that I always say that Japan is in perfect timing for the aging population and exponential technologies. If you see the way of substituting like the aging population, for instance, in Tokyo, there are many elderly people driving taxis. Just they they should just retire and enjoy their life and do other things and just let the self-driving taxis to take Tokyo. And in that way, agriculture as well. There are so many robotics in agriculture. So that's my guts. I don't have any specific set of data. I'm collecting the data to make the hypothesis more concrete and more data driven. But my gut says that Japan is the best country in the world to be in the best timing for transitioning into a more advanced society, society 5.0, if you want to call it, or exponential technology society, if you want to call it. So applying all these technologies into the areas and the jobs that are needed and will be needed. And as you say, Maya, perfectly, this could be the way of positioning Japan again as the leader. So when people ask me, hey, Jovan, why are you here in Japan? And my reply is like, I have a mission and I want to help Japan and Japanese people to position themselves in exponential technologies as a leader in the world. So I strongly believe that this aging population is an opportunity more than a problem. And as you can see in exponential technologies, they reduce the price every year. So in the beginning, it's going to be very expensive, but Japan has the resources, as you were saying, Ren, for the GDP and enough capital for affording this creation of these new startups and this new innovation. But they will reduce the price, and eventually they will be affordable enough to be exporting and to be sharing with all the other countries that are aging, like in Latin America, for instance, etc. So I think that's a very, very good opportunity for Japan and the Japanese society.
Indeed, yes, it looks so and sounds so. And well, we've got also Yuka. Good morning, Yuka. Oh, for you,
Good
it's
morning.
good evening.
Yeah. Anyway, thank you. Thank you again for a great conversation, guys. And Jovan, so ever since I've heard your first installation of this topic, my interest in robotics has been a little heightened. But I'm not saying the mechanics and technology of robotics are way over my head. But I have a question on application of robotics. So along the line with what you're talking about, like improving the quality of life, actually for everybody. And I so happen to see this article. It's actually 2019 article. This company called Inoffice has come from the, like you were saying, the research department of university, Tokyo University of Science. And I wonder if you are familiar with this Inoffice. And I think they are working on something like heart walker. And I don't know how, because I read this in Japanese, so I don't know how to spell heart walker. This walker has been developed by Mr. Hart. I think it's in Europe somewhere. And what this walker does is not really, the typical walker. It helps the people with walking disabilities, as a result of disease or as a result of accident. So I really got interested in like robots as not only a caregivers, like they sort of can even help people who are bedridden, that sort of to help them move around on their own. So again, this technology was thought of or in the process of developing in 2019. So I got to think technology has to be improving ever since. So one, could you sort of share, you are more like knowledgeable and informed about this, so I like to learn how the robots can help everybody improving the lifestyle or lives in general. Thank you.
Thank you so much, Yuka. Very interesting question. Absolutely. I think I had a great experience coming to Paris all summer in 2019, and I realized how the scooters, the electric scooters, they became almost like a garbage. You could see it everywhere in Paris, and sometimes even in the middle of the sidewalk, and not parked well or abandoned. It was so strange for me to see so many electric scooters. So since then I've been thinking, yeah, that's it's not exactly a robot, but it uses batteries, it uses a motor, so you are transported at your wheel without any effort. And I think that's a very simple, like so simple example. I don't say robot because a robot, from my point of view, it needs sensors, it needs actuators, and it needs a processing. This needs three things. But the electric scooters, they have circuitry, they have processing at least a little bit, and also they have actuators. So it's kind of a halfway robot, if you can say that. But it could be expanded, and of course, I can foresee the future. For instance, that you want to be telepresence and immerse completely your reality with on your side to have all the actuators and all the feelings as if you were in London, in Paris, wherever you want to go, and just use this robotic like armor that goes around. So suddenly you, instead of seeing a lot of electric scooters, you could even see like robots walking around, and it's not exactly you being physically transported, but it's more the experience of you being uh, conducted around the city, etc. So, and of course, there's the exoskeleton, as you were mentioning, that helps people with disabilities to make the legs stronger. And there's could be many applications. For instance, when you want to climb a mountain and you've been very tired in the last months, but you still want to go to the mountain, this could help you to enjoy it. And you can just put your very easy to put suit and just start walking Fujisan, for instance, and without a lot of effort, you could do this, enable these physical activities that were not possible uh, or were difficult if you didn't have them. And in that way, also, like uh, maybe another, there could be other applications as well. So what is needed is just maybe to understand the problem. You have to see what is the problem. Why is this happening? Like you have to wonder, like why we humans are doing this in this way. So it doesn't make sense. So once you realize that, like, oh, then you start to research about the problem, and you say, okay, this problem has these features, these characteristics, and then how you can implement a robotic solution for solving this problem. So that's what I would advise completely, is just to understand the problem, and around the problem just to embrace it and to understand it very well, so then you can plug as a robotic solution on it, and it could become organic. And I personally believe that for Japanese people it could be even more organic to understand this robotic solution onto a problem. So I think that would be the methodology that I would suggest, and I strongly recommend every time that embrace the problem, talk about the problem, dream about the problem, and then you can implement it with any of the technologies, the solution.
Right. Again, thank you, because I used to have a more negative view on robotics. Maybe like I've been influenced by Hal in that movie. But anyway, but then, like you said, anything and everything, it's depend on how we can apply to our programs. So again, I thank you for your, like you sharing your knowledge and experience and research. And Maya and Timothy, thank you again for putting this club. Thank you.
Yeah,
Thank you, Yuka.
thank you, Yuka. And actually, to Yuka's point, and Jovan, you mentioned this in the previous room that you did. there seems to be a higher acceptance of robots in Japan. I recently read an article, and I can't remember where I read it, but basically it was saying that Japanese elderly were surveyed, and there was a preference for having the caregiver be a robot over being a human being. And when I think about that, I mean, I'm sure those attitudes toward robots in general in Japanese society and culture has to be part of the motivation for the innovation of it. And I guess my question is, how important is societal acceptance of robots, in making them more, part of everyday life? In other words, if other societies have a similar resistance that Yuka said she had before, will that hinder it, or do you think other societies will change as they become more familiar with the technology?
That's a great question, Timothy. Thank you. I think both, to be honest, and it could be some case by case. Some one is like adopted culture or like inspired culture. Like another is just the need that they have the need and they really need to do it, so they change. And we can see it very easily with the masks, for instance. How in France, how people were so against this Islam culture of covering your face for females. There were so many people against that, and and then because of the COVID, the corona, everybody has to have a mask and have the half the face covered. so so they really need to transform a very fundamental cultural feature in France. I dare to say that it's even more than America, to have your face uncovered and to show off your face, to change it and to adapt it because of the need. So in that regard, also the exporting the culture, like you can see anime manga everywhere in the world, and I'm not very versed in anime or manga, but I have many friends in America and in Latin America who know so much, and there are so obscure references and so many things that they know that I don't know at all. I might never know. So I think this exporting this culture also is happening, and the adoption in the later years. I think Korean culture became more popular, at least in America and some parts of Latin America as well, as I understand, even Europe. But Japan has always been present, and I think from food, everybody loves sushi in America. Like I don't know really, literally anyone in America who doesn't love sushi. To food or ramen, for instance, they love ramen so much, and thus this cultural assimilation of Japan might come also in combinations towards the assimilation of robotics, maybe not in the same degree as naturally Japanese people are, but I think it will happen. And I think these two combination and depending on the country or the society, case by case, but both influences will be playing a role. And hopefully when Japan enables these new technologies and this new innovation, it could be adopted very quickly, especially as we said, if the cost and the price is reduced every year. So we could be able to export robotics technology even easier.
Jovan, thank you for your insights. Thank you for this conversation. We appreciate your presence here very much. And let's continue. Well, probably in September. Again, thank you to everybody who stuck with us during this 1 hour. Thank you for this. We wish you a great day and see you again. Bye.